Hey everyone, in this video I'll demonstrate evaluating derivatives using the product rule. Now, as the name implies, product means we'll be looking at functions that are multiplied together to give us a product. So in order to use this rule, we'll need to have a function that looks something like this. F of x is equal to g of x times h of x. That is something of x multiplied by something of x. And what I like to do is evaluate this derivative using a little mnemonic or memorization technique that I have created that reads a little bit like this: d12 plus d21. It's as simple as that. Every time you see a d, you will take the derivative, and every time you just see a number, you'll just rewrite that number. So let's have a look at an example here. I will go ahead and rewrite that mnemonic. d12 plus d21. And let's say our function f of x is equal to x cubed times 2x squared. So the first thing I like to do is label the parts of the derivative that we are multiplying. So I'll call this one 1, and I will call this one 2. Now, it doesn't matter what order we label them in. This one could be 1 and this one could be 2, because we are multiplying instead of adding or subtracting. And so with that said, let's evaluate this derivative, f prime of x. And we'll follow the formula exactly as it reads. d1, so the derivative of the first term. Well, using the power rule, we know that the derivative of x cubed will become 3x squared, and we'll multiply that by 2, the second term. So we'll rewrite 2x squared. Okay, we will add d2, or the derivative of the second term, which becomes 4x times 1. So we'll rewrite the first term, x cubed. Now, usually at this point it's good enough just to leave it like this, but I will simplify for you. 3x squared times 2x squared, well, 3 times 2 is 6, and x squared times x squared becomes x to the 4th. We'll go ahead and add to that 4x times x cubed, well, that becomes 4x to the 4th. And now we have two numbers of the same base, x to the 4th, x to the 4th. So 6 plus 4 is 10x to the 4th. And that is the derivative of this function. Now let's have a look at another problem, this time a little bit more complex. I'll go ahead and rewrite d12 plus d21, the power rule. And let's say that this time g of x is equal to 2x cubed times ln of x. Okay, first thing I like to do, of course, is label 1 and 2. And eventually, once you become comfortable with the product rule, you won't need to label them. But for now, in the beginning steps, I'll go ahead and label every time. So in order to find g prime of x, the derivative of g of x, we'll follow the product rules formula in order. d1, the derivative of the first term, using the power rule, is 6x squared, times 2, the second term, ln of x, okay, plus d2, the derivative of the second term. Now, if you recall, the derivative of ln of x is 1 over x. And we'll go ahead and multiply that by the first term, which is 2x cubed. Okay, so simplifying all of that, 6x squared times ln of x, there's nothing in common here, so we'll just go ahead and keep it as 6x squared ln of x. And we'll add that to 1 over x times 2x cubed. So we'll have an x in the numerator and an x in the denominator. So we can go ahead and cancel out at least one of these x's. That will make it 2x squared. and that is in its simplest form. Okay, hopefully that made sense. In the next video, we'll have a look at the quotient rule and then the chain rule. Thanks for watching. Be sure to subscribe below for more videos and help with math and calculus.